Let's learn about the differentiation. Differentiation is a calculation process to obtain functions' instantaneous rate of change. Let's take a look at the concept of function's change rate through the linear function. The change rate is a rate of y change, an x change. The change rate means the value of y, increasing amount, divided by x increasing amount. For the linear function, the change rate is constant anytime and anywhere. However, as functions such as the quadratic function and other functions get complicated, the change rate gets complicated as well. So when a certain interval is set, the change rates within the interval are average change rates. Certain point x within an interval has a different value most of the time, so an average change rate can be thought as a representative, which is not the change rate of a certain point. Instantaneous change rate is the changing interval is finely divided, and the change amount of x gets close to zero. Differentiation function as below. Taking a limit of average change rate, x's change amount converge to zero at a particular point, x of a function, the multiplied of f and x in technical term. Let's think about a roller coaster that we rode at an amusement park. Do you remember the tension as the roller coaster climbed up the steep rail slowly? Wasn't it scary when the roller coaster stopped at the very top peak, even if it was for a short moment? Roller coaster climbs up, the instantaneous change rate increases and stands on top, at neither increase nor decrease. X point is the limit, and the value of function, the multiplied of f, and x, is the maximum value. In this case, the multiplied f, and x is equal to 0. Roller coaster comes down, the instantaneous change rate will be decreased. There was real-life examples of differentiation. Detecting the speed of a car on the road uses sensors from 2 points and measures the change rate of speed between them. And instantaneous acceleration, the instantaneous change rate of the differentiation of a high-speed train that runs 300 km/h, is adjusted. Train leaves from the first departure, the acceleration gradually increases. Train gets close to the arrival station, it should reduce the speed to stop. Since the distance from the departure station and to the arrival station can be known, calculating the instantaneous change rate and differentiation to figure out the points of acceleration and deceleration.